Okay, we're going to use Plotly to make your graphs. You can make graphs using Google Sheets. It's not quite as powerful as Plotly, and even though Plotly is a little convoluted and frustrating at the moment because they have a new version, the more you use it, the more comfortable you'll get. Most of what we want to do, I'm pretty sure, is free, though it looks like they're adding some things that you might have to pay for at some point down the road. But it's a really good tool here, so let's try it out. So you'll go to Plotly, plot.ly. You might want to create an account for yourself. It is free. And then you're going to be making a chart. We're going to ultimately be making a graph here. And you have two places to work with here. Notice you have your data table up here and your graph down below. What you'll be graphing are your average values rather than trying to graph all of your data points. You want to graph your average values, and you'll be entering them up here in this chart in order to make your graph. I'll go ahead and do that and show you what we can do. So the first thing you have to do is enter your data here that you want to make a graph of. You can cut and paste that out of your Google Sheets, I believe, or you can enter it manually. I've got columns here for uncertainties. Notice that if your uncertainty is all the same for all of them, I can just grab this corner, drag it down, and it'll copy that value for me. But the cool thing about Plotly is you can add different values of uncertainty for each data point if you want to. Notice my column headers up here, I haven't made them all fancy like we did in our data table because it's just not as important here for our graph. What we want to do is make a scatter plot, and now we choose what's on the X and Y axis just with these drop-down menus. For this graph, usually you'll put your dependent variable on the Y axis, your independent on the X. We're going to do that opposite for this particular experiment. So I want time on my X axis, which is column B. And on my y-axis, I want distance, which is column A. Notice I can switch these anytime I want to. And you can see here that we have started to make a scatter plot. Looks pretty good. Why don't we add some error bars to our data points? Notice I've put values in here for, in these two columns, I put the values for my uncertainty. And again, I can vary these if my uncertainty varies. I click here and add error bars, and I choose my vertical and horizontal. Time is going to be, or distance is my vertical, so that's column D. Time is my horizontal, so the uncertainty is column C. And another little nifty little button right here, I can get rid of this data table and look at my graph more easily. Now I'm starting to get a really nice graph. The next thing I want to do is add a line of best fit or a trend line, and that's under the analysis section over here. Click on the analysis tab, and then up here click analysis, and you want to do a curve fitting. So we choose which data set we want to add a trend line to, and in this case it's this first one, and it's not looking linear to me, so I'm going to choose quadratic and see how it goes. I run my fit. Trend line looks pretty nice here. It's fitting the points pretty nicely. And a good way to test and check to see how well your trend line fits your data is this thing called an R-squared value. R-squared value is called a correlation coefficient, and it lets you know how closely that trend line, the mathematical equation for that trend line, how closely your data points fit that. And an R-squared value of 1 is the best you can do. Usually it's between 0 and 1, and the closer you are to 1, the better. If you collect raw data rather than the numbers that I made up, you won't be at 1, but 0.99 something or 0.98 something is quite good. What I'd like to do is add this as an annotation to my graph, and notice that it adds the R-squared value, which is a good analytical tool, as well as the equation. And you can click and move that however and wherever you'd like it to be on your chart. Your graph's looking pretty good now. You need to enter a title, and it should be descriptive. So, distance versus time for marble rolling down and flat. That's a pretty descriptive title. You need to add titles for your X and Y axes as well. And you can do that just by clicking here. Let's try this. There we go, clicking there. And this is this was time and t in seconds. Great. And do the same thing over here. Distance s in centimeters, for example. Boom. There's my graph. Now all you have to do is get it into your Word document. There's a variety of ways to do that. I can take a screenshot and crop it and insert it as an image like that. I can also come over here to export, but I believe maybe I have to save it before I export it. So I want to save it. Yes, we'll click save. It'll probably tell me I have to pay for it or something. No, we'll save the file publicly. Everyone can view it. Now I can export it. And I can, when I export it, I can download it. Unfortunately, to save it as a PDF, you have to pay for it. That's the Pro feature. But as a PNG file, I can download it. And then if I just show this file in a folder, there's my folder. I'll put that over here for a second. I'll go back to my Word document over here, and I will insert an image. I would like to upload it. There it is. Shoom, we'll upload it there, and hopefully this will all work. There's my chart. Now, for some reason, it's not including the line on this. We'll have to play with that. That's pretty weird. So the other option is just to go back to your chart and take a snapshot of it. So here I have a snipping tool. I can just take my snapshot like that, make a copy, and then go back to my document and paste it. Let's see if that works. Much better. So you'll just have to play with what works best for you, but that's what we're looking for with a nice graph here. You've got your plots pointed, you've got a good title, your axes are labeled, you've added a trend line, you've got an R-squared value and an equation for your trend line. These are all going to be powerful analytical tools. Remember, for this lab, you're going to be making two graphs, distance versus time and distance versus time squared. All right, good luck.